Okay, guys, so we are going to be finding the sum here, and this is given to us in our summation notation. So we're going to be using the same kind of formula that we did yesterday in order to put this through our series. So we're going to be using our S sub n of n over 2 uses 2 times our first term plus our n minus 1 times our common difference. So we're finding the sum of this series. So what we're going to do first is I'm going to switch it from our summation notation into the series notation. So we're starting at 1 and going to 18. So this is going to be S sub 18. So our n is 18. And our difference, our common difference, we talked about this the other day, is actually the piece that feels like our slope. So it's in the slope location here. So it's going to be 1 over 2. And we're going to calculate our a sub 1 and our a sub 18 so that we have those values here. We at least need our a sub 1 because we need our a sub 1 here. So a sub 1, we're going to use our rule here, substituting in our 1 for k. So it's going to be our 1/2 times 1 plus 7. So our a sub 1 is 1/2 plus 7, or 7.5, or 7.5. So, I mean, I guess we don't need our a sub 18. I have it written down here for some reason. I don't know why. Love that for me. So much fun. So what we're going to do is we're going to use this formula up here in order to get our summation. So S sub 18 is going to have our n of, I don't know what that was, 18 over 2 times the quantity 2 times our a sub 1, which is 7.5, plus our n of 18 minus 1 times our common difference of 1/2. And I am getting squished out here. So what this is going to give us is it's going to give us 9 times our values here. 2 times 7.5 is actually going to be 16. Plus our 18 minus 1 is 17. 17 divided by 2 is going to give us 8.5. So our summation is going to be 9 times our 24.5. Also known as 220.5 is the sum from 1 to 18. That is terrible 8. So that is our sum from 1 to 18. Let's do that again. This one's not given to us in summation notation. We are actually asked to write it in our summation notation and then find the sum. So in order for us to be able to write this in our summation notation, we need to be able to figure out our rule. We need to find our n. We need to figure out all kinds of stuff on here. So I'm going to start with labeling the pieces that we know. I'm going to call this guy A1. I'm going to call this guy A2. This is A3. And this, we don't know what number term it is. We have all these ellipses in here, so I don't know which term it is. We're going to have to figure that part out. So we don't know that one yet. What we can do, though, is we can find our common difference because we do have some sequential terms here. Since we have sequential terms, I can find the common difference because I can figure out the difference between 19 and 8. 19 minus 8 gives me a common difference of 11. So this is our common difference, that variable d. So we can find our equation, or at least our function rule, where we take our a sub n and we use our a sub k plus n minus k times d. And we can find the equation for this. If I find my nth rule, I can use my a sub 1 in order to do that. So we're going to have our a sub n equals, if I do a sub 1, that's going to get put an 8 here, plus n minus 1 times our common difference of 11. So that's going to give us 8 plus 11n minus 11, which is going to be, 11n minus 3. So that tells me my general rule. So when we're going in our summation notation with a sigma, we know our rule is going to be that 11n minus 3. We just don't know where we're going yet. We don't know how many we have. So the way we're going to do that is we're actually going to take our rule, set it equal to this, and figure out what our n is. So I'm going to take my 16,805 and set that equal to my 11n minus 3 so we can figure that out. So we're going to go ahead and add 3 to both sides and get 16,808 equals 11n. And then we're going to divide both sides by 11 to get 1,528 equals n. So we're going from n equals 1, which was our start here because we had a sub 1, to our last one in our summation is 1,528. So that's how we write that in our summation notation. From that, we can get our sum using the formula from the last problem. We were going to take our S sub of that number, 1528. Ooh, that was weird. There we go. And we're going to use that formula where we take our n over 2, 1528 over 2. We're going to have our brackets. And we can do the same one from the last problem, or we can do the other one that we talked about on Tuesday where I take my first term and my last term. And we do our 8 plus 16805. And in one this big, it's probably going to be easier than using the one from the last problem because, because these numbers are so much bigger, using the decimal and fraction one, it still will work. It works just fine. It's just going to wind up grosser. So when we simplify this, when we solve this, we're going to wind up with a final value of 12,845,132. So when we're given a series, we have to figure out our rule so that we can find our n so that we can write it in the summation notation. We're going to do one more with our sums before we go on to the next kind of thing. So this one is given to us in a different way. We're asked to find the number of terms. So we're asked to find n. That's what this is, number of terms. So that means we're going to find n in the sequence that has these conditions. We know the first term, I know my common difference, and I know my summation. So what we're going to do is we're going to take our sum. So we know S sub n, the formula for that, because especially when we only have a1, we know that's n over 2, that's a 2, n over 2 times 2 a sub 1 plus our n minus 1 times our common difference. Well, I know an awful lot of those pieces. I know that my sum is 21. We have an n over 2. I don't know n, so that's not super helpful there. I know my a sub 1 is negative 2. That's up at the top here. And then we have n minus 1 times my common difference of 1/4. Okay, let's simplify this and see what pieces we can get here. So I've got my 21, my n over 2. We've got -4 here. And then I can do this multiplication over here. We're going to have our 1/4 n minus 1/4. And again, I can simplify here. N over 2, -4 minus 1/4. That's going to be minus 17/4 plus 1/4 n. Or you can put it as n over 4. In fact, I think I am going to switch that to be n over 4 just so that we're keeping everything, wrong pen, really similar. And then you have a couple of options here. You can either do this as a distribution here, or we can work to get rid of the fractions because they're really super gross. So I'm going to go ahead and do our distribution, and then I'll get rid of my fractions. So we're going to have our 21 equals, I'll change the view so you guys can, there we go. So we're going to have our negative 17n over 8, because we're multiplying across, and n squared over 8. So we're going to multiply both sides by 8 so we can get rid of that fraction here. And that's actually going to give us 168 equals negative 17n plus n squared, which is starting to become significantly more familiar. This is a quadratic. It's got an n squared in it. So we're going to go ahead and solve this by factoring. So I'm going to set it equal to 0 and get it into our standard notation. So I'm going to subtract 168 from both sides to get 0 over here. And then I'm going to write this in our order, in our normal order, where we have our squared term first, n squared minus 17n minus 168. And then we're going to try and factor this to find our solutions. So we're going to need a pair of numbers that multiplies to get 168 and adds to make negative 17. So I encourage you to think and look and pause and look for it pretty quickly. So we're going to have our negative 24 and a positive 7. So my factored form is n plus 7, n minus 24. So my possible solutions here are n equals negative 7 and n equals 24. So I want us to think about which one of these might be our actual solution here. Because remember, n is our number of terms. We're counting things. I'm doing it 2 times, I'm doing it 3 times, I'm taking 6 terms, I'm taking 7 terms, I'm taking 24 terms. I can't take a negative number of terms. I can't add things up. So this is not relevant. So we cannot have a negative n. So that's not a valid solution. So this sequence has 24 terms. There are 24 terms in this sequence. And that's kind of the end of our summation stuff that we're working with today.